Good morning, everyone. Thank you for joining this session as part of the openBIM Awards 2024.
Down before I hand over to Kenneth, just a quick overview. Of course, there's a lot of use cases, practical use cases, but also more theoretical that you need to solve when you're delivering a Dataportal solution. We've listed some of them here, and it ranges from how do we go towards next-gen IFC, IFC5 format, how do we support the thoughts that are in that framework, through more specific things like how do you extract data from an IFC file and put it into a database, because that's the format that we need. How do you geolocate? If you want to display data on a map, a BIM model on a map for the end users that don't have access to specific BIM tools, how do you geolocate and put that information into IFC4 and display it on a map? It's a very practical use case, but very important for the users. How do you construct a front-end OpenBIM viewer, etc. But Kenneth will dive into some of these use cases now.
Thank you. First, our OpenBIM information. In this project, we are using IFC beyond its traditional role as a file format, and instead seeing it as an exchange language where we can use it to integrate data across different systems, ensuring that our data remains both accessible but also sustainable for the long term. A crucial part for this project is the use of a data dictionary and information delivery specification. They help us define clear exchange requirements. This ensures that when we have data flowing between systems, that it actually makes them valuable and reusable. We have seen that data is often trapped within specific systems, making it difficult to actually share or integrate into other workflows. So in this Dataportal project, we are exporting BIM data into IFC format and then making it accessible via an API. Then doing it this way, we can centralize the data and enable a broader use and do easier integrations. So for us to actually do this transition from file-based to API-based, we are using IFC OpenShell. That works. This diagram, it shows the end-to-end data workflow where we export from our source systems in the IFC format, and it's exported as a file. These files get sent to the data hub where we use IFC OpenShell to convert it into three key formats. We have data, we have 3D geometry, and we have 2D floor plans. We store the files in a data lake, and the data itself is loaded into a database where we can query and manage it more easily. This includes a table for documents, which actually has a link to its related file as described in the IFC standard. Then on top of this, we have implemented an API, which provides access to all the data, including the files. This makes it possible for system to only receive the specific data they need, eliminating the overhead of processing unnecessary data. And then for our key outcomes, a big challenge for us is the exchange layer versus the business layer. In this project, we see IFC as a common language for exchanging data between systems. While each system probably handles data differently, they should be able to actually map and exchange it using IFC. When we have worked with mapping IFC classes, we didn't find it that challenging, but when it comes to properties and quantities, things get way more complicated. So we have chosen a gradual approach where we are implementing the IFC schema based on specific use cases. A data dictionary is definitely essential in this process. It allows us to define languages and map them together, ensuring that when we see a term in any system, we know exactly where it belongs in the IFC schema. This allows each organization we're working with to maintain their own terminology while ensuring that we are consistent across our systems. So we do think that the key is to focus on mapping internal business terms to the IC schema rather than enforcing organizations to change their language. For my last slide, at KEJD, we aim to embrace openBIM standards rather than depending on our suppliers supporting the standards before we can actually use them. This allows us to adapt and evolve our practices according to our specific needs and not be limited by our suppliers' lack of implementation. By prioritizing openBIM, we also position ourselves to actually be able to innovate and enhance our processes continuously. A significant challenge in implementing IT systems like the Dataportal is securing the needed resources with the knowledge to do it, and also getting leadership to actually invest money into data governance and the whole setup to make a solution we can actually count on. Looking ahead, IFC OpenShell has been essential for us to go from the file base to having it in a database requires some conversion, and it played a key role. We find processing speed to be critical. We need standardized methods to actually share and stream this geometry between different systems. And IFC OpenShell for now is perfect for our use cases. Then we see APIs along with the IFC 5 standard as key to the future of data exchange. We believe the idea of focusing on modular system where systems do a few things well instead of trying to do everything. And we think this will provide some flexibility in our system choices so we can actually pick the systems that complete a use case the best way.
Yes, and just in closing, a key participants, by now you know Kenneth and me, but our boss, Michael Friis Ørsted, we also would like to mention him. He couldn't be here today, but he also played a key role. So if you want some management perspective on this project, feel free to contact him. He's also a well-known face within this building smart community, we believe. But the last point here is if you want to chat about our solutions, do's and don'ts, our experience, etc., so look us up or feel free to contact us. Thank you.
Thank you both. Apologies for the technical troubles in the middle. Thanks for bearing with. I'll go quickly to the jury. Quick questions. We don't have too much time. 1 or 2 questions, if we have them.
Thanks for the presentation. A question about, you explained a data hub and also a front-end web interface. Can you explain a little bit more what that means for the end user? Can the end user download, for example, an IEC file or not?
I can take it. You can hear me, right? For the data hub is the storage of data to actually give the end user access to see across all our systems. Let's say we have 10 systems with data combined around. We combine them in the data hub, and then the user without license, needing licenses and so on, they can actually access this front end and get access to see where they should go to actually edit this data. That's the point.
Yeah, and also elaborating on that, one of the main principles with the data hub is that data should be accessible for everybody who needs them. Also files, IFC files. If I want to use an IFC file to do some calculations of some sort, I can access it in a data portal, but it doesn't mean that I managed it. So data management is really, really important here. You can't change anything in that file because that needs to go through a process where it's validated and put into the data hub, et cetera, et cetera. So that's why the data governance part of this also actually plays a big part. But no user should have not have access to all what we know in the data portal.
Okay, thank you.
Anyone else, or are we happy? Yep, go on, Casey.
Thank you. Good presentation. Jakob, I particularly liked your comment. I think you said, of course, we don't want to create our own data model.
Yes.
You'd be surprised how unusual that is. A lot of people do create their own data models. I think my question would be, the use cases that you listed in one of your slides were very much use cases about how you implemented IFC and the various different resources that Building Smart have on the technical side. Do you have a catalogue or a list of business case uses for the end user? Similar question, but how does that impact the real world FM?
Yes, of course, the end user doesn't really have any interest in these OpenBIM-based use cases, but there's lots of use cases that we, on a practical level, are trying to solve for this. Meaning, for example, if you work in our customer service department in KEJD, sitting with help desk tickets, and you want to access information today, you have to look for it in different systems and in emails and in lists, etc., etc. So there's a use case who fits perfectly with the Dataportal. So you can access all the data here. You can use it in your help desk system and pull the data over there, or you can access the front-end Dataportal and look at what's going on here with the building. Where's the lease contract? Are we doing any planned maintenance work on this building? Who should we contact if there's anything that we need to know in this building, etc., etc. So you can combine all this information in the centralized data model where it fits on different shelf and expose it to, which also helps their daily work, so to speak. So.
That's great. Thank you both for the answers there. That is the end of that category, and we will move swiftly on to the handover category. So I would like to invite to the stage colleagues from Electrical and Mechanical Services Department, the Government of Hong Kong SAR. We have Steve, Gary, Beverly, Allison, and Mohit taking to the stage. Thank you.
Good morning. I'm Steve. These are my teammates, Beverly, Gary, Allison, and our consultant, Mohit. Thank you for inviting us to Morocco, joining the openBIM Awards. Our presentation topic today is revolutionizing handover practices for E&M projects by embracing various openBIM technologies into BIM asset management lifecycle. Teammates will soon introduce it to you. Have you ever experienced when receiving a handover BIM model where there were missing objects, missing attributes, missing color, or even having the equipment shipped outside the room? All these, what we call poor data quality, make it extremely hard for maintenance party to carry out maintenance and operation activities. It also makes it hard to be upkept in the whole build asset life cycle. But why do we care so much about the data quality and handover process? We are from Electrical and Mechanical Services Department of the Hong Kong government, which is one of the biggest maintenance agents in Hong Kong with more than 75 years of experience. We oversee more than 1 million E&M equipment and systems in over 8,000 government venues. Information of all these equipment assets would ultimately store in our asset management platform. So you can imagine quality data from the BIM models is crucial for us to carry out effective maintenance in all those venues.
Yes, Steve. So contractors from different disciplines, they always prefer using different BIM authoring software. So receiving BIM in different format is very common in the industry, which also means an organization will need to require various software in order to view and to make comment to the models, which is very costly. And the staff will have to acquire different knowledge in using the software. But openBIM, in this aspect, is having an absolute advantage in solving these issues. So if all the submissions are in the IFC format, then the organization will only need one solution to handle all the BIMs, which means the staff can save time in acquiring different knowledge in using the software. The company can also save costs, And the most important thing is, by using the same language and the same standards, it can enable a seamless collaboration for all project stakeholders, as well as to greatly improve the interoperability, which can greatly reduce the project life cycle. So having all these benefits from the openBIM, we are all eager to try it out. EMSD therefore engaged with some of the contractors to carry out some trial projects in the handover aspect. And this is what we observed. So this is a BIM from the MIMEP project indicating a chiller plant. So when we received that in the IFC format, and we found that all the equipment were hanging in the mid-air without the framework and with all the hanger missing. So we tried to get back to the project team and feedback to them on our findings, and when they tried to open it on the computer, all this framework were there. So what had happened? So it turns out that it is a very common issue that we heard from the trade and the industry, that when they try to convert their BIM from a native format into the IFC format, they often experience different level of data loss, including the missing objects, missing attributes, missing colors, and shifted objects. So all these have made them hard to move on to use openBIM. Even if they can manage to generate an IFC file with a complete set of objects, they still have to undergo a tedious process in identifying and rectifying all the different types of errors being found in the model, which mostly caused by the human input error. And very often these errors could only be discovered after the handover process. And what makes it worse is these erroneous data hindered our future system integration. So with our experiences in the E&M industry, we have developed a highly customized requirements in order to facilitate the handover process. However, as technology advances, there are always new systems and new equipment. So when all these new requirements arises, how can EMSD manage both the new and the existing equipment effectively? At the same time, so that a contractor can be timely updated with the latest information. We also learned from our experience that contractors always like to submit their submission in the native format. Therefore, EMSD has already have a native-based workflow, handover workflow in place. But today, that is no longer sufficient. So while we are studying and embracing openBIM and try to develop an openBIM workflow, handover workflow, how can EMSD at the same time maintain both the native and the IFC workflow effectively? So Gary, to take all these challenges, EMSD has conducted a study in early 2024, right?
Yes, Beverly. We have many pain points, and obviously it could not be solved by only just one single tool. So what we did is a toolbox of solutions. Our toolbox leveraged 4 openBIM standards. Okay. Oh, thank you. 4 openBIM standards, which is bSDD, IDS, BCF, and also IFC. This toolbox includes the first and the largest public dictionary in Hong Kong, which could save 90% of time saving for us when there's an update of the requirement. And through the implementation of IDS and BCF, we have contributed back to the BSI community with over 40 rounds of data idea exchange and discussions. And we have also established IFC conversion guidelines to help improving the quality of openBIM handover. The process, we have adopted some new tools, and also we have developed some new ones by our own. As you can see, there are 6 green boxes highlighted in the workflow. In the left, there's the native BIM workflow, and also the right one is the newly implemented openBIM workflow. And so let's get into details. First of all, the attribute requirement repository, the ARR. Rather than in the form of PDF files, we have turned our 75 years of E&M handover requirement into a database, and that's the ARR. This database is very important because it serves as a single source of truth of our requirement and generate both a human-friendly version of our requirement and also importantly, the machine-friendly data files. But what are they for? These machine-friendly data files can be then pushed to 2 converters, also by us. A bSDD JSON file and IDS XML file will be generated. With this automation, when there is changes of the update on the requirement, 90% of time saving can be done by doing this automation. And with the bSDD JSON upload to the BSI cloud server, it is the first and largest public dictionary in Hong Kong. And how complex it is, let's see. It's 380 classes, 1,800 properties, and more than 7,000 of class to property relationship. That's quite a lot because we manage E&M equipment. We then use the API connection provided by BSI and develop this Wi-Fi plugin, you see here. Because this plugin can then tap onto the bSDD directly. And then you can help the supply chain to create the attribute confidently, efficiently, because it just tap on the cloud and it will be automated. And it can save tens of hours each time for each project. But most importantly, project team can save have a better QA and also attribute consistency when they're doing the native BIM. And still remember equipment hanging in the air? That's it. Even project team are not using IFC for editing, it's okay, because we have developed a IFC conversion guidelines, which also include a mapping file to help to specific to our asset requirement, so that no matter which version of Revit they are using, they can still export to IFC with confidence, without data loss, without missing object or the coordinate shifted. And as you can see, the missing hanger, missing framework is now coming back. And also using the IDS schema, we are able to carry out 4 types of attribute checking, which are very important to us. Our IDS is directly tapped onto the bSDD, and thanks to the BSI community, our requirement enhancement was done, and you point our request, and it can now support our very complex validation requirement. With that, we have tried out using our headquarters BIM, and you can see here, and it can be used. It was used to validate with various market available IDS checker. Our building consists of 15 IFC files with more than 37,000 of E&M assets. And we have proven that rather than just using days to checking, using this automation can just less than half an hour is required to go through very complex, comprehensive checking and generate all the outstanding issue in a BCF file for further review and rectify. So the project team hand over to us will be more swiftly. And since IDS is a relatively new standard, we have tried not only using one IDS checker, but 3 different solutions, one from Finland, one from Italy, and one from United States. But yeah, so that ensuring our methodology is really feasible, and it can broader community can enjoy and benefit from it. It's not only bound to a certain brand. So these are solutions to the Handover pain points.
Thank you, Gary. So for the evolving requirement of the bSDD, we have developed our asset requirement repository, which serves as the single source of truth, and upload our requirements to the bSDD, which also supports storing different versions of our requirements. So through this automation process, it has saved us more than 90% of time to handle any new requirement in the future. And within only 9 months of time, we have contributed our requirement to the bSDD and become the first and the largest public dictionary in Hong Kong. To solve the tedious job of the data validation, we have created the IDS and BCF-based data dictionary rule set and incorporate that into the IFC handover workflow. So now the contractor can download our latest requirement from the bSDD anytime and anywhere, and to run with our defined set of the rule set for validation. So with this vendor-neutral QA/QC process, hours of manual checking could be saved. We have also established the IFC conversion guidelines and the automation tools to help solving the data loss issue of the E&M equipment during the handover stage when they try to convert it from the Revit to the IFC format. So all these are not easy to be achieved without close collaboration, right, Mohit?
Yes, Beverly. So during the development of automation for the bSDD and IDS generation, we were in continuous coordination with the BSI technical team. During the project, we have transformed roughly 1,800 bSDD properties and 7,000 plus IDS checks for the project. The BSI technical team has also helped us to refine the bSDD schema itself to support various edge cases. For example, they have increased the regex expression length from 200 to 3,000 plus characters to meet the project requirements. In addition, We also thank OpenBIM software vendors to make timely revisions to their platform to support the OpenBIM and IDS. For example, one of the software vendor has improved their IFC import workflow so that it can cater the complicated requirements from the project bSDD and IDS. So by showcasing the overall transformation process through an IFC-based workflow to the trade and industry, we hope we can push the OpenBIM adoption in the asset management lifecycle.
Thank you, Mohit. To bring OpenBIM adoption further, we are most happy to share our findings and tools to any interested parties. We look forward to collaborate with multidisciplinary stakeholders for more trial projects as we go together with BSI community and improve on the OpenBIM standard. We are dedicated to cultivate a stronger OpenBIM culture to enable more OpenBIM usage and demand for OpenBIM solutions so that the entry barrier to the OpenBIM industry can be lowered and increase market competition in future. Thank you.
Thank you very much to the team. We'll take a couple of questions if we have them. Helga?
Yes, thank you for the presentation and also for showing you have OpenBIM not only sharing data but also you promote sharing the knowledge. And that my question is about one of the big challenges that you identified is the data loss or the deficiencies in the IFC export. And you mentioned that you fought that and developed something. So can you elaborate a bit more on how you fix that? Is that something that you do like an own development? Do you use that in-house? Do you use that, do you give that to the providers? Do you do that for all the native softwares? Or do you make that available also beyond your specific workflow?
Yeah, thank you. Thank you for the question because it's a very interesting question because many practitioners in Hong Kong, they want to try IFC, but this is a very great challenge for them. Oh, they are missing. Then why they hurdles for them to try IFC? And then we see that, in E&M industry, that's what are focusing. The mainstream software is Rapid. And then we try, why they were missing? And then we found out that, actually it's not, the tools can convert to IFC already, but why they are missing? Because they this E&M objects, what we focus on is not included in the default mapping files. So what we did is we define, these are important to EMSs so that they have to be included in the IFC files. And then we have the mapping file, and also they can do, I think, about 80% of the steps. So they just input our mapping file and then just follow our guidelines and take, and then next step, okay. And then the files is already there. So it can serve our very complex 380 something of the equipment type. And even they are not included in the 380 something. We have also tried it. And the project team can just like the hangar we have shown you. It's not included in a 380 something, but also they have the needs so that we have also guidelines to tell them, if you want to map and make it happens, make it visible in the IFC, you have to create the mapping yourself and then just import to the export to that's actually already inside or Rapid for 222, I remember.
So basically, for example, let's say we have a mechanical equipment and we export to IFC. It will be mostly an IFC building element proxy. So what we did, we created a mapping table of 400 plus IFC entity and which element should export to what IFC entity, so that there's no information loss when it's exported in terms of geometry, in terms of default semantic, and in terms of additional asset information we are creating through BSD. So there's a mapping of that 400 plus entity for the project. And it's, since this is a public organization, it's open for everyone. Everyone can use it and export the IFC efficiently.
Yep. For these data loss issues, so we have provided a EMSA created guideline for them, and also we have prepared for them a configuration files that they can import to the tools when they try to run it. And all these configuration files and then guidelines are all free for the industry and trade. So we we'll put that on our website. So everybody, anyone, contractors, suppliers, or even users, they can download it from us and use it to facilitate the handover process, or even their project, the way of doing the project.
Thank you, everyone. Blimey, that was a bit loud, sorry. Given the length of the question and answers, I think we'll wrap it up there and move on to the next category. So thank you very much, and we will move on to technology. Our first presenter in the category of technology is Shawn O'Keefe. He is representing BIM and Scan and is online. So Shawn, can you check that we can hear you, please?
Yes. Can you hear me okay?
We can indeed, so please go ahead. We do have the 14-minute limit. Given that you have no sight of the timer, I'll set one here anyway and give you a heads up if we're reaching it. Thank you.
Okay, thank you. So BIM and Scan OpenOp is an openBIM lifecycle management cyber-physical platform. And today we'll be discussing mostly our validation and construction tools, but also the rest of the ecosystem. We have three main offerings where we customize OpenOp for major clients on the left-hand side. In the middle, we have a subscription basis where you can use all of the tools that we're seeing today yourself. And we have over a dozen APIs, which we offer connection to OpenOp for different things. For example, we have Revit plugin API and these types of things. So key participants, over the last few years, we've modified and customized OpenOp to help Ericsson deploy its Ericsson Site Digital Twin system for over hundreds of users and capable of handling millions of site projects all over the world on all continents. The bottom left-hand corner is an actual representation of these environments and their deployments, and there's a publication you can read about that. Other example client and use cases predominantly around the use of AutoCore and AutoGen for buildings, infrastructure and roads, waterways, airports. We work with semiconductor facilities, water treatment facilities, pharmaceutical facilities. Currently, we're modifying OpenOp in that domain at the moment. Of airports, of course, telecommunications, tunnels, opera houses, nuclear facilities, theaters. And over the years, we've had over 400 plus subscriptions in over 54 different countries. So to start off with, we use IDM and MVD process thoroughly, creating BPMN models based on IDM for every single exchange within our system. There is no exchange without utilizing this process. And then also I do a value add assessment on top of that to continue to make these processes leaner over time. And this is the standard IFC software build methodology that should be deployed within all IFC-based systems.
Sorry, Shawn, just to interrupt you, we're not seeing a progression of your slides. Are you?
You're not?
No.
Oh, okay. What if I do it this way?
Yeah.
Can you see this?
We can, yeah.
Okay, you can see the slides now.
Yes.
Thank you. Okay, so this is the only one you saw so far?
It is, yeah.
Okay, okay. So here are the different deployments. So on the left-hand side, customize OpenOp. In the middle, subscription-based, and all of our APIs as well. So to recap, the Ericsson Site Digital Twin customization of OpenOp, the major clients in the middle, and the subscriptions in countries where we have used these technologies. And as I was mentioning, our business process models based on IDM for every single possible implementation within our system, and then also value added assessment. And this is the proper way to create IFC-based systems. So this is where I was, and let's get back to it. So our key project information around the validation and reconstruction tools. So as you can see on the left-hand side, creating models from point clouds is not easy business. And you can also have a very beautiful model in the end, and maybe it's not all the way correct. So that was the Budapest State Opera House Here's Zanzibar in Dublin, a project that we worked on. And you can just imagine getting a point cloud like this and having to create a model and then also say that, stand over that it's accurate and so forth. So over a decade ago, I was introduced to a few problems in the semiconductor facility, number 1 and 2 there on the screen. And we can see that installations, which would be that point cloud, deviates from the model. And also there's many times when models are not correct. And spot checking for issues within models is basically impossible for humans to get it right. And 3 there is a water treatment facility where a point cloud is overlaid on top of a model. And people are contracted these types of projects to find all of the deviations and where things are on site that are not in models. So you can just imagine that traditional method and then using, for example, AutoCore in this case, to automatically detect all of the deviations and the things that are on site that are not in models, all within a user specified tolerance. So just because you have a pretty state opera house there does not mean that it includes everything that was contracted to actually be modeled for you. So our main objective with all of our solutions over the past 11 years is to reduce subjectivity and create 100% objective scientific solutions for our customers. Spot checking just doesn't work. So our patented technology around AutoCore, to keep it simple, is a user can specify the tolerance that they want to compute and find automatically correspondences between the models, whether it's a design, as built, or whatever, and the point cloud of that given state and time. So through our easy user interface in the cloud, you can simply just select your IFC model and the point cloud that you want to run it against and select your tolerance. So we made a very complex computational problem very simple. And this is the end result, which is a semantic point cloud. And this is actually the core patented technology where the point cloud actually inherits the IFC data based on its entity object that it is corresponding with and in deeper relationships. So just like IFC, E57 is the open standard for point clouds, and that's an extensible file format, the same as IFC. But just like IFC, if you're going to extend something, you need to do it in a standardized way. So we have a topics manager based on BCF, of course, and a BCF API. And AutoCore automatically creates BCF messages and camera viewpoints to easily streamline the design review process when analyzing the model for what is matching and what is not. And the objective is to go ahead and create BCF topics where, in this case, issues are marked up and sent to the individuals who actually need to correct these models. Excuse me. So we've taken it a step further with openCDE and allowed the streamlining of the process. Of course, if you remember the business process models and the value add assessment, where we're analyzing to how do we prevent non-value added tasks like downloading and uploading. So openCDE allows this exactly. So you can imagine something like this model that is on the left-hand side that is out of tolerance. And the objective is to update this object and the rest of the model as well based on the BCF messages that were sent to the design engineers. So openCDE in this case for our system is deployed within the Azure cloud and allows the easy updating of these models in this way. So you can see just a linear look at this from left to right, where the model was found out of tolerance by AutoCore, the BCF messages using openCDE, and the point cloud and the IFC model with openCDE is updated and then synchronized into OpenOp on the right-hand side, where you can see the model validation has occurred. So AutoCore also has other heat maps, both relative and absolute. In this case, a relative heat map is used for floor flatness analysis to meet ASTM 11 standards. And these can also be captured in BCF and sent to other systems and these types of things as well. So the heat maps can also be used, in this case, in conjunction with our BIM query builder, where we filter out quickly all of the structural elements and conduct structural steel deformation analyses. and then we can save these as BCFs and send them back to Tekla and whatnot. We can do tank deformation, obviously, with the heat maps. So in this case, you can see faintly there is a deviation in the blue area there where the tank is actually deforming beyond how it should be. And this could be captured in BCF and sent to other systems to analyze and rectify the situation. So we also have AutoGen as a solution, which automatically creates coordination view, model view definition files. Okay, so a basis of design, LOD 200 type models, automatically from point clouds in IFC format, and all of these are proper IFC doors, walls, columns, and so forth. But the problem with creating things automatically that we've addressed is AutoCore, and that's where the AutoCore algorithm actually comes from, which is automatically checking automatically generated models. So by using these two technologies in conjunction, we can quickly update the model, and we can send BCF messages similar with the AutoCore workflow to modelers for creating their drawings, but also updating the objects. And an openCDE workflow with AutoGen looks like this. In this case, I'm using ArchiCAD to quickly connect the components to the library within ArchiCAD and prepare this model for drawings, while also using AutoCore to validate it as I go. Okay. So AutoGen automatically creates IFC spaces and zones and these types of things as well. And these are very useful for in the very, very early stages of the life cycle, where build-in programming tools like a NUMA system or DRufus can use IFC spaces and the data within them, or energy analysis tools like IES and so forth can use these spaces as well. OpenOp also has our own customized web point cloud viewer, which works very well, and you're welcome to try it. We have a BIM query builder where endless open BIM querying of BIM data is possible. There's so many different combinations. You're literally only limited to what you can actually think of when using this type of querying on top of proper model view definition files. So speaking of those files, here is actually an electrical systems information exchange model for the telecommunications industry, where we are filtering out systems and we're actually seeing the flow of electricity through these telecommunication systems for every individual port. So when you have properly defined model view definition models within a system like this, you can do simulations that are not possible in other systems, like seeing the flow through systems and validating these systems. Okay, you could further then open up the point cloud in this case and see the flow of electricity through these systems and how the site is actually working, and how do you want to amend these systems going forward. In this case, it's for a retrofit, and serialize these instances as BCFs and send them from the field using our mobile device, which I'll show in a moment, into OpenOp, where people in the office can further do their designs and approvals. Okay, so here you can mark these things up using the mobile device or OpenOp in the web, and you can communicate these from the field in the office or to other office personnel in other offices. We have a product library that is very robust, and its backbone for verification purposes comes from the specifier's products information exchange model view definition. Okay, so this is a model view definition that actually defines how do you put data into objects prior to them being used for creating models, hence drawings, right? And that's when they go from a type to a component instance. We also have further verification and validation on top of that specification, where we check to make sure product data is there, 0 error reports for Kobe data. That is, if you're familiar with how SPA works, that that data is within there in spreadsheet physical file format, actually. So speaking of that, our system allows for both Part 21 and Part 28 ISO 10303 formatted data. What that means is you can import Kobe files and share them directly via API with Maximo and other systems. And here's the East Dormitory project that we wrote a book for and so forth, which is here. So if you want to know how to properly overlay FM data on a coordination model view definition and reap the benefits of these types of BIM queries, you can start by using the book there. Okay. So speaking of other model view definitions that the system supports correctly, in this case, this is a water systems information exchange, where I can go ahead and query and validate the flow of the systems, or use this during design to better select components for the design to meet the overall requirements. In this case, I created that model in ArchiCAD, and that is freely available to the general public if anyone wants to use it. So our mobile device here is, this is on an Android device here. You can download it from the Google Play Store, and you can use this on your projects with OpenOp. And using the BCF API, all communications, whether they're early design related or later in installation phase, actually using underneath the hood the COBE model view definition for construction requirements, to send that data back into the database and further build that data of your digital twin in a very structured and verified and validated manner. We can also send instructions and jobs to different personnel, and this is actually capable. This is part of the Ericsson Site Digital Twin as well, and we can send these jobs to anyone, anywhere on the whole planet, basically.
Sean,
so
I'm
this
going to need to ask you to wrap up as quickly as possible, please. I have added a minute for the slides, but please come to a conclusion.
Yep. So the overall ecosystem that was built in this case for the Ericsson Site Digital Twin starts from left to right, from the surveying to design using the product library, to the overall middle phases of design, and then the install and build and using AutoCore, and then finally that data in the database being used for operations. So building a system like this is done in this way with the conceptual model, creating the model view definitions, the software solution based on IDM-based exchange requirements, and then deploying a system to the general public. Basically, it looks like this. Every type of exchange has its own very specific specification. And if you want to see how all of this is done to create a system like this, it's in this publication here. And thank you very much. And sorry, I went a minute over.
Thank you, Sean. I know how disappointed you were not to be able to make it in person. We do appreciate you being online. So we will move quickly to the next presentation. Yoshiyuki is taken to the stage representing ONESTRUCTION. When you're ready, please get started.
So welcome to my presentation. I'm Yoshiyuki Miyauchi. I worked for a startup company called ONESTRUCTION as Chief Technical Officer. So here is a brief introduction of my company. ONESTRUCTION is a Japanese tech startup that provides openBIM implementation and educational solutions. We are the largest sponsor of Building Smart Japan. We are designing the rules for openBIM in Japan. So today's presentation will focus on enhancing openBIM workflows. What are openBIM workflow enhancements? How can we enhance the openBIM workflow? We believe that a system for the realization of openBIM enhanced workflow is needed. To do this, we will start with a review of openBIM. openBIM is a common language in the construction industry. We call openBIM lingua franca. A thinker once said, "One does not inhabit a country, one inhabits a language," he said. "Language is our motherland," he said. Again, I say, our language is our motherland. Our language is openBIM, right? Which is our motherland where openBIM is the common language? In other words, our motherland is openBIM. Our beloved motherland is openBIM. With openBIM, the world will again be connected and united. Now, there are patriots in our motherland, right? There are many patriots in OpenBIM as well, IOC, IDS, BCF, and more. It's an excellent motherland. We have prepared a solution package for motherland. This is the solution package needed to support our motherland and its patriots. It's a solution package called the OpenAEC, Systemized Solution Package Optimized Construction Workflow. OpenAEC is a solution package consisting of a web application and the desktop plugins. OpenAEC is also a system in which BIM authoring tools and the BIM collaboration tools are linked to strengthen the connection. This is precisely what we call the system for patriots, sons of the patriots. So let's introduce the concept of OpenAEC. First, more openness. Openness means making it easier for more people to understand and appreciate. Promoting understanding accelerates the use of OpenBIM. Next, more business evolution. More reliable, more quickly, more sustainability. Actually, the OpenAEC logo is a reference to the hydrologia. Like the hydrologia that changes color to suit various soils, OpenAEC flexibly adapts to the changing era, bringing OpenBIM solution to more people and more challenges. Now, let's look back at the OpenBIM workflow. A simple optimized workflow that starts with need and ends with deliver. To realize OpenBIM, this workflow must be followed. Map the OpenAEC series to the OpenBIM workflow. OpenAEC is a solution package consisting of a web application and desktop plugins. Web and desktop solutions are interlinked to optimize the system. As you can see, OpenAEC supports all OpenBIM workflows. This is the rationale for why OpenAEC covers OpenBIM workflows. I will now explain how to use the OpenAEC series according to the OpenBIM workflow. The Need tab allows you to capture the data you need for your business. Data capture can be approached in a variety of ways. We have placed a button that accesses UCM as well as importing from local and CDE. Users of OpenAEC can immediately access UCM. The Require tab of the OpenAEC series web application allows the creation of IDS and bSDD. Creating an IDS requires the skills of an OpenBIM professional. But with OpenAEC series, users don't need high-level knowledge. User-friendly features exist in OpenAEC. This makes the value of OpenBIM workflows more easily understood by the organization. Next, we will discuss the creation of bSDD. We have designed many bSDD dictionaries. We fully understand the difficulties designing dictionaries because we have designed many bSDD dictionaries. OpenAEC reflects the feedback of our experience. The IDS and bSDD information created by the OpenAEC series of web application will only be of value when connected to a BIM authoring tool. With OpenAEC for bSDD, a desktop plugin, you can do it. OpenAEC for bSDD is a dedicated plugin for BIM authoring tools supporting Autodesk Revit and Civil 3D. The created IDS can be instantly imported into BIM objects and tied as properties of each object. No more time consuming many properties assignments. Everything is done accurately, reliably, and in an instant with IDS and bSDD. Of course, bSDD information can be imported into BIM objects. Choose the dictionary you like, choose the class you like, and the properties associated with the class will flow into the BIM object. You can also select a language from the dictionary. This provides interoperability between languages. The user selects an object by category and decides what properties to assign. Searching through the large number of classes in the dictionary and selecting a class will display the properties associated with it. The user simply selects and grants the correct information from the allowed values in the dictionary. This is the true value of bSDD as a single source of truth. The problem for many people is when exporting an IFC from a BIM authoring tool. For example, it takes some effort to export properties in Revit. At least 2 or more configuration files are required. However, with OpenAEC for bSDD, you can automatically generate those configuration files in an instant with a single button. Of course, you can produce an IFC with classification organized. Users are no longer forced to think about difficult things when exporting IFC. The Produce tab of the OpenAEC series web application loads IFCs created in the BIM03 tool. It allows for basic viewing such as measurements as well as IFC compositing and cross-section creation. To make use of the exported IFC for construction management, a variety of information searches are required. The Produce tab can be used to solve various IFC issues that BIM authoring tools are not able to handle. IFC data can also be immediately reflected in the dashboard to see what properties are included. Many dashboard templates specifically for IFC is available as a web application. Anyone can build a dashboard by simply importing IFC into a web application. This can make the IFC naked. Our communication will be further accelerated by IFC dashboards. No more need for Power BI. The Require tab of the web application allows various checks and pointed information to be assigned to the IFC. IFC checking using IDS and MVD checking using MVD are available. The results of the checks can be corroborated by BCF. The checked results can also be output to PDF to show the client your batches. Let's use OpenAEC for your batches mission. There is also a link to the IFC validation service as an external link, so users can immediately access the IFC validation service from OpenAEC. It's also possible to send out reviews for members of your team to check. The Deliver tab of the web application allows IFC data to be exported to other CDEs. IFC can also be converted to copy files. The converted copy file can be used for handover. Our OpenAEC will contribute to the success of strategic projects because at the core of strategic projects is OpenBIM. As a fully OpenBIM compliant software, OpenAEC will accelerate business sustainability, increase value, and develop human resources. Software that is fully compliant with OpenBIM workflow will bring prosperity to the industry and BSI. Our OpenAEC is already in use by companies around the world. Currently, 47 countries have confirmed their use. Even companies that have not touched OpenBIM before are realizing increased business value and sustainability by using OpenAEC. It's proof that happiness to OpenBIM is spreading around the world through OpenAEC. Hydrangeas don't bloom with sadness. They bloom because of the happiness created by OpenBIM and OpenAEC. So in September, we signed a global MOU with Autodesk on OpenBIM. We will collaborate our OpenBIM implementation capabilities with Autodesk's global network to bring OpenBIM to more people. For the prosperity of the industry and BSI, OpenAEC is unlocking the future, making the language of patriots easier to understand and bring the fruits of OpenBIM to many people. Finally, please watch the promotional video that sums up our passion, enthusiasm, and determination. Let's show. Sorry, audio, volume up.
Today's industry process is diverse, with various stakeholders exchanging a wide range of data. To optimize the process, an openBIM workflow that moves a lot of different data back and forth is needed. OpenAEC is a very powerful package solution for openBIM workflows, various solutions in one package. Plug-in tools for collaboration with BIM operating tools. IDS allows for automatic IFC verification, supports improved productivity. Plug-in tools to the cloud can work with CDE. Even companies that have never touched OpenBIM before realizing increased business value and sustainability by using OpenAEC. OpenAEC optimizes the construction process with OpenBIM and unlocks the future of the AEC industry.
Okay, let's search OpenAEC. So, and please buy our products. That's all for my presentation. Thank you.
Thank you very much, Yoshiyuki. So the next presentation will be Michelangelo, who is taken to the stage and will be representing ACCA software.
Thank you. Okay, so hello everyone. I am Michelangelo from ACCA Software, and today I would like to talk to you about usBIM.IDS, IDS for everyone. I think that we all agree that IDS is a fantastic idea. That's because it is the ideal tool to clearly define the information that needs to be included within the IFC files and also to verify them. What it is, IDS? Well, it has been created to be a standard, and as such it is essentially a data format defined in an XML file. But to ensure that it is appreciated and most importantly adopted by all industry operators, we need to give it live with tools that make it accessible to everyone. When you first approach IDS, the difficulty is understanding its potential, possible use cases, and you even start questioning its usefulness. And this is why we talk about education and training. So, in addition to presenting the book on IDS titled IDS for Everyone, let me explain why at ACCA we decided to write it. It all started from a statement of our CEO. A standard like IDS will truly be the standard only when it is adopted by the majority, if not all, operators in the SE sector. And then, since the beginning, we contributed in the analysis and the testing of the IDS standard through the development of applications implementing it. We also actively participated in the so-called serious games conducted at various BSI summits, where there was direct interaction with the possible IDS users and where we really understood the real challenges encountered in its application. And it is precisely these challenges that made us share the acquired know-how in this book so that IDS can quickly become accessible to everyone and truly be the standard we expect. The book, as you can see, is composed of 10 chapters and 174 pages with theory, practice, and exercises, and is freely available in 6 languages. So then we have the difficulty of creating our IDSs, which is something that we can solve with the help of a powerful editor tool that accompanies us with a natural language for its creation. So we can create specifications in which we set up our needs by defining filters, that is the entities that we want to check, and the requirements in the form of properties, classifications, materials, but also, of course, required values and restrictions. But specifications can quickly grow, and when they do, it is difficult to understand them and what they mean. And that's why a natural language explanation is always available, that can be included also in legal documents and tender documentation, for example. The properties, classifications, material, and so on can be searched directly from the bSDD, the Building Smart Data Dictionary service, which is seamlessly integrated into the application. There is also the possibility to generate the regular expression with the help of AI, by explaining the desired pattern in natural language. And last but not least, there is a direct integration with the official audit tool from Building Smart in order to guarantee that the IDS is valid against the XML schema. Next, we also need, of course, to validate the correctness of the information of an IFC model, which is not easy without a checker tool that allows to easily interact with the content of both the IDS and the IFC. We can validate an IFC or a federation of IFC models against one or more IDSs. And if there are related informations that are available on the bSDD, it is possible to consult directly the page with all the details. The result of the verifications process is that we obtain a detailed report that shows the issues that have been found. And of course, we can expect which one to see the entities involved and the details of the problem occurred. Other functionalities that are built on top of the validation process allow, for example, to color the model based on different specifications, which is especially useful when you have IDSs with the many specifications at once. It is also possible to put the labeling of the error occurred directly on the entities on the model. And last but not least, of course, the possibility to export the validation result as a BCF, the BIM collaboration format from Building Smart, for further collaboration with other applications as well. So there is another strong need that is often arises, which is the one that we need to model, correct, or integrate the data that is in an IFC file with the information that are required by the specifications of the IDS. So it is possible to specify the missing data of the entities, which means that we can edit and enrich the IFC model in real time. The validation process is triggered again for such specific entities, and if the values are expressed in the IDS as a list of possible values, things are even easier, since the user has just to choose the proper one from the list. This possibility to edit values, also for multiple entities at a time, is especially useful when there are many specifications. More often than not, in fact, entities are failing on the same requirement at the same time, but require the same values. So this bulk editing allows to quickly make most of the FC model compliant with the specification. And when we say that IDS should be for everyone, we really mean it. Like in this example, where we integrated via APIs with a BIM authoring tool. In this case, it is Revit from Autodesk, but it can be any other BIM authoring as well. You can edit everything about the model directly in the BIM authoring interface, but once connected, the Revit model and the IFC model are synchronized together, which means that every change that happens in the Revit model is reflected on the IFC model and vice versa. Of course, basic functionalities, such as, for example, selection, but also the IFC hierarchy and selection are available, as well as the IFC model data with all the IFC properties directly available in the authoring. But of course, it is also possible to do model validation with IDS directly into the BIM authoring. Here, validation, editing, addition, and deletion of properties are all available. And of course, this enhances familiarity for the user, which can use functionalities from their preferred BIM authoring tool, Revit in this case, to check the errors of the IDS directly on the BIM authoring and edit it. This process of editing the model and updating it to make it compliant the IDS with the IDS specifications make both the Revit and the IFC model updated. And in case the properties should be searched from the bSDD, of course, there is integration with such service, where again, directly from the interface of the authoring, you can access the bSDD. At this point, I think it's clear that with IDS, we can get normalized IFC models with all the necessary information required. But if I need to obtain many IFC models controlled by IDS, the need for the automation of the verification process arises. It is possible to schedule automatic checking of IFC models and IDS files at predefined days and times of the week by selecting the models and the specifications involved in the verification process. Each run of the validation will have all the details with the dashboards and the statistics. And it is, of course, always possible to get the related BCF validation report for sharing. And last but not least, it's possible to go into the detail of each of the IFC model checked to see what happened with that specific run of the checking to see all the details. So automation that we have just seen allows to obtain standardized IFC models so as to be able to, for example, build models on a large territorial scale with normalized information that can be used by other systems as well, such as GIS. So it is important because we are using IDS, which is an open standard, to take the data from the openBIM models and transfer to another system, which in this case is GIS. But of course, you can think about every kind of external system as well. So this allows, in the case of a GIS, to obtain geospatial digital twins and smart cities. So let's see this in action. Here we can see a direct integration of the openBIM world and the GIS world. And we can see how we can access data from a typical tabular GIS form, resulting in the selection of the entities of the FC model. And the same is true vice versa, where by selecting objects on the IFC model, the GIS table gets filtered as well. BIM data queries and statistics directly in GIS are also possible, like, for example, the possibility to find objects in a certain radius. Each of the objects has all of the BIM data directly available in the GIS world, thanks to the use of IDS. Another example of a special query can be, for example, about the energetic classes of the rooms of the buildings, again, gathering the data from the BIM world and transferring in a dynamic way to the GIS world via IDS. And it is always possible to refer to other BIM data as well, such as, for example, attached documentation and so on. And everything becomes even easier when you have a copilot with AI that accompanies the operator in the complex phases of creating and using the IDS. So the AI copilot simplifies the IS workflow in every aspect. It starts by verifying the IFC model against the IDS specifications, and then it can help in adding new ones from the descriptions. By selecting some of the entities that I want to include in this new specification, the AI will automatically suggest a proper filter for the IDS specification, asking for modification based on the available data in that IFC model and other similar project and data from the user, so that the user can customize it. The AI then will also suggest some requirements for such entities. Again, the user can edit them, but the AI will try to suggest the best one given the available information about other projects from the user. So when then there is the validation, it can happen that some of the entities are not part of the specification. The AI can also change the AISC class of the objects to make now them into the specification. Starting the validation process, then the user can start to specify the values that are missing that the AI will ask. it can bulk edit the entities of the specification, but of course it can go into the detail of each one. For example, the AI will ask for the needed values, and the user can look for similar values from other entities or take measures directly from the model. So at the end, by iterating this process, the AI will guide the user, which finally will make all the IFC model compliant with the IDS specification that he has just created. So our solution as BIM.IDS has all of these essential tools integrated into a single system that simplifies and streamlines every step of the information management process with IFC models. The diffusion and adoption of IDS, we think that will largely depend on the availability of adequate tools. These tools not only will facilitate our daily work, but also will allow us to make most of the potential of IDS, improving the efficiency of our projects and promoting interoperability and innovation in the BIM sector. Thank you very much for your attention.
Thank you, Michelangelo. And the last presentation now will be from ZWING Innovation Limited. I see Kevin making his way to the stage. Apologies that we will run into the lunch break a little bit. It was always going to do that. It will run a little bit more than expected. So thank you for continuing to stay with us.
Good day, everyone. We are ZWING Innovation, and I'm excited to introduce ZWING openBIM Checker, an independent platform for auditing BIM across the entire lifecycle. Our solution addresses key challenges: ensure data consistency, automation, and compliance with industrial standard. It integrates with openBIM standard, including IDS, bSDD, BCF, openCDE, openGIS, and AI chat, powered by RAG, providing a seamless BIM data auditing process. First, let's address some key pain points in BIM auditing. One of the major challenges in BIM project is data inconsistency. Discrepancy between the stakeholder and tools often lead to errors in efficiency. We want data remain consistent across all project phases. Manual data validation in BIM project is a labor-intensive and prone to errors. We want to automate this process, saving time and reduce the risk of the human errors. Meeting the LODI framework requirement for the non-geometrical data in BIM model is crucial for accurate project representation. We want to ensure compliance with this standard as well. For instance, in a 15-story building, manually validating nearly 2 million parameters across 12,000 assets would take over 640 man-hours to identify missing properties, values, and errors. Our data validation tools significantly enhance the workflow efficiency, ensure data consistency, improve collaboration, and reduce errors. With our solution, a BIM model LODI assessment can be complete in just under 5 minutes. 5 minutes. So now let's take a quick walkthrough of our ZWING openBIM Checker to see how it operates in a real-world scenario. To use ZWING openBIM Checker, start by logging into the system and upload your IFC model. So next, add text to the IFC and upload and the access information schedule, we call AIS file, which will be automatically converted into IDS in our system. So in converted, and then you can view the model and select the IFC along with the IDS to perform an LODI verification. Once the validation is completed, review the LODI index and checking results. Then access the detailed report with recommendations, you can highlight objects within the model to view their properties conditions. So the detailed report is very comprehensive. And of course, you can see the final Excel output as well. You can highlight the object and see all the property condition, which has an error, which is the missing parameters. Very easy to understand the dashboard. Finally, download the detailed Excel report, which includes correction guideline. This is very important for the practitioner to know where are the errors. Very comprehensive. As a vendor-neutral platform, our solution integrates with various BIM and CDE platforms. Now let's check out the key OpenBIM information. The ZWING OpenBIM Checker process map streamline BIM auditing by converting access information requirement ARR into a machine-readable IDS format. We make use of the bSDD framework, able to populate the data direct to the model, ready for IFC export. The model is then exported in IFC format and validate against the marking scheme, IDS, to ensure compliance. Issues are managed via the BCF manager with the detailed report generated and GIS integration for enhanced visualization. The ZWING OpenBIM Checker software ecosystem integrates with the BIM and CDE platform for data consistency. The IDS converter, standardized value, enable the bSDD connector to automate the property retrieval and the application as mentioned. Also, our built-in AI-powered IDS chat with the RAG enhanced user interaction by providing instant context awareness response. So the bSDD connector automatically retrieve and apply models properties, reduce manual effort, and enhance accuracy. This process improves interoperability between the BIM platform and ensure that all project data aligns with the industrial standard, leading to a more reliable project outcomes. So the properties can be selected and apply the bSDD. You can also search the keywords. Just click created, and then it populates. As you can see, the BIM objects now validate and populate with the accurate standardized parameters and instant. Let's take a look. Before the validation process begins, our platform utilizes the proprietary ZWING OpenBIM IFC exporter, specifically developed to support the native BIM software, including the Revit, the Tekla structures, and soon to be ArchiCAD as well. By using our custom IFC exporter, we guarantee the model is throughout prepared for check against industrial standards, laying a strong foundation for our reliable and compliance auditing process. The ZWING OpenBIM Checker validation mechanism ensure the type parameters such as the type name, CAD code, and manufacturer remain consistent across the all object of the same type, while instant parameter like location level, access code, and installation date are unique to each individual object. This approach ensures that our platform goes deeper and validate both the type level consistency and instant level uniqueness. Ensure the BIM model is both accurate and compliant with the industrial standard. The Universal Access Information Schedule, AIS template, is used to define the parameter names and categorize them based on the client-specific standards. These parameters include the important codes such as the CAD code, Unicode, along with their corresponding parameter values. Our system analyzes this data, recognize the patterns, and then convert into the information into a machine-readable IDS format. Just click and it converts. Our validation workflow integrates across the entire project lifecycle based on the OpenBIM workflow. It starts with the preliminary check to ensure type parameter meet the basic requirements. As the project advances to the design stage, more detailed check validate both types and instant parameters for accuracy and consistency. During the construction, exact check ensure full compliance with the LODI 500 standards. These comprehensive workflow maintain the data integrity with BCF capturing issues for better collaboration. Starting at the initial stage, preliminary check ensure the basic parameter of the BIM model align with the project requirements. As the project moves into design stage, more detailed categorized check conduct, focusing on both type and instant parameter to ensure they are meeting the necessary standards. During the construction, exact check validates every model elements comply with LODI 500 standard, ensure accuracy and completeness, remain consistent compliance and accurate from planning through to the construction. So the openBIM checker connectors BCF manager is a vital tool streamline the issue resolution process after the BIM validation. Take a look. It automates the document any identified issue in the BIM collaborative format, BCF, providing detailed information on their location and nature within the model. This issue can be accessed and addressed directly within the native BIM software like Revit, ArchiCAD, or Tata Structures, allowing for real-time collaboration among the project stakeholders. This seamless integration ensures that the problems are resolved quickly and efficiently, reducing the project delays and maintain the quality and compliance of the BIM model throughout the project lifecycle. Here we explain how our openBIM checker plugin for Revit and Tata Structure foster close collaboration between the BIM team and project team. The quality assurance rectification cycle ensures the ongoing framework. After initial validation, any discrepancy communicated via the BCF manager and synchronized back to our cloud platform, enable real-time collaboration to resolve the issues. The BIM team make adjustment while the project team reviews to ensure changes align with the project objective. So we have an integrated openGIS into our solution as well. So enable the BIM model to be overlaid on map for enhanced spatial awareness and project coordination worldwide. The LOD index is clearly visible on the openGIS map, allowing to access the project directly with just one click. Looking at your right side of the screen, may I just ask the machine of the platform, how can I improve the LODI index of this report? So the answer, yes. Our AI power chat, driven by retrieval augmented generation RAG, is designed to seamlessly bridge the gap between the AIS and IDS for data for BIM information auditing. This innovation approach allows the user to interact with the openBIM data, provide a real-time answer related to compliance, access details, and report specifics. The RAG workflow begins with the text embedding generated from user question and BIM data. This embedding proceeds through the semantic similarity search to retrieve the most relevant information from the SQL database. The AI model, powered by a small language model, finds 3 minutes. Then formulate the accurate and context-aware response to ensure the user receives precise and actionable insights in real time. Finally, let's see the delivered key outcomes. The ZWING openBIM checker offers a flexible categorized checking system that is designed to accommodate both global and local requirements. These features allow the platform to adapt to international standards such as the COBE or other open standards, while also support the local regulation and standard like the Hong Kong Construction Industry Council LODI requirements. The flexibility of this system ensures the BIM model can be validated against a wide range of criteria, making it suitable for diverse project environments. Whether a project requires compliance and with global framework or adheres to the specific local guideline, the checker can efficiently categorize and validate data to meet their needs. The ZWING OpenBIM checker scalability enhanced by its seamless integration with both OpenBIM and OpenGIS, making it suitable for the project at both global and local scale. This integration allows for the combination of the BIM model with GIS data, provide a comprehensive spatial context that is crucial for understanding and managing the complex project. Here are some real-world examples of our solution in action, showcase the effectiveness of our tracking, particular to MEP system, and reporting capability in various AEC projects. Our success is powered by a dedicated team of experts in OpenBIM and programming with R&D, who have worked tirelessly to develop and support this solution, making them a stable and strong team into OpenBIM development. So thank you for your time. We believe ZWING OpenBIM Tracker represents the future of BIM auditing by OpenBIM, and we look forward to opportunity to help your project success anywhere in the world. Thank you.
Thank you very much. So if I could now invite the other finalists in the technology category back to the stage. I can see two of them making their way up. And we have Shawn online, of course. Ra, could I ask if you could get Shawn up on the screen? Hi, Shawn, we see you. So I am going to probably limit this to one question to each of the presentations. Who would like to start?
I have one question for the first presentation for Shawn. How do you, in the auto-correction module, how do you distinguish irrelevant deviations from relevant ones? So you probably have different tolerances. For example, how much a shape can deviate or how much the position might deviate. Do you have a list of tolerances and how do you apply them?
Yeah, so the list of tolerances would be in your contract, depending on what the tolerance is for each discipline model, whether it's the electrical model, mechanical model, plumbing, and so forth, all have different tolerances. And even within those specifications in those contracts, the tolerances are specified different. You can run all of the different models at those different tolerances. And to answer your question about the correction, the validation of whether something is within tolerance enough is a validation question that is answered by a human, in this case within the BCF topics that are issued. So that's one of the purposes of the BCF topics and how those topics are signed off and approved. Okay, so there's also a heat map in the repositioning of objects, and only real advanced users would use this heat map in this way. But it's the absolute heat map where in the middle range would show you how to correctly position that object. And we have an algorithm that in the future will automatically reposition these objects for that perfect fit. But again, to answer your question, the validation of an object within tolerance that is found, its correspondence, is a human one. And that decision is made and sent and approved via BCF.
Thanks, Shawn. Let's have a question for one of the others.
Question for usBIM, Michelangelo. You stated it's IDS for everyone and you simplify things. Can you elaborate a little bit more about the complex use of bSDD in combination with IDS? And is there a lot of questions for the end users, or do you yes?
Yes. Yes, thanks for the question. Yes, there are a lot of questions from the end users. And this is what we found during the presentation. I showed that we followed the IDS project since the beginning. So from the very early stages, we started to implement and testing it and proposing it to our users. And the point is that when you use it inside our community, the Building Smart community, then people are already aware of it. So in some sense, they already know what they could expect from it. Then the application can be a little bit harder or easier to be used, user-friendly or more or less. But when you go outside of the community, and that's where we want to go with IDS, that's why it's IDS for everyone, because we think that it's a very important standard that should be used by every AEC industry operator with different use cases, like, for example, the one that we have seen where we transfer data to another system, the GIS system in the example, but other systems as well. And then it's where things start to get hard, because users are not aware of it. They don't know what it is, how to use it, but also what possible use cases they can solve, how they can benefit from it. And then, as we have seen also from previous presentations, many are already using it and are putting in those presentations the benefits. So we want to go this step further, which is basically to get to every user, which means that even normal people outside of this community should be able to understand it. And that's why we start with this book that goes from beginner to expert, to then make them aware of the standard and to find their use cases that can be solved with the standard, how they can benefit from it. That's it. Thank you.
Thank you. 2 other projects for questions. Do you have one, Casey, or? Okay.
I have so many questions, but I've been asked to ask one. But I'd like to ask one question to all of you. As technology providers, what is the most significant gap or challenge with the IFC or OpenBIM products and services that are currently available to you? So as quickly as possible, please.
Go on, Swings. I can see you.
Swing, yeah. So we developed a platform from ground up to now the product, the technology platform. I think the most difficult part, the gap between the users and the development is sometimes, I think, first of all, the IDS, how to get the users understand the IDS comes in and how to become is a marking scheme so that it can check their data accurately. And we solve this by creating a very simple converter and then make it into a very simple Excel sheet AIS so that it makes everything they understand already. They don't need so many learning curve, and then they can adopt the BIM, the OpenBIM benefits instantly with our platform skill. So when we develop, we always think about if the user should be like 1 click or 2 click, then get the result. So we create lots of dashboard so that they can easily understand what is the ongoing status of our of the checking and auditing. And also the AI is helping a lot because for a common user, they just asking question and then get the result, get the insight from the report. Of course, the education to the user is very important during the process. So we have a support team to make sure the users, when they use the OpenBIM or understand the OpenBIM, they are training, and we have an online education, YouTube, everything provide to them, and then we have a support team to them. So that's why I think the OpenBIM concepts is not difficult to understand, but what we do something which is to their pain point, to what they not understand, so that they use the technology to make the life easier. So this is our approach. Yeah.
Thanks, Kevin.
Can I speak?
Yeah, please.
Yes. So our mission is only one. So our mission is to use technology to make OpenBIM more accessible to the masses. So we will combine the better accept of technology to provide more people. That's all.
Thank you. Go on, Shawn.
Yeah, for us, we don't really have a problem with user adoption of the technology too much due to the use of IDM and business process modeling before we even create features for architects or engineers or mechanical engineers and all of these different types of users. Sometimes when a user is not qualified to do certain things, like they might not have a surveying background and they want to use a point cloud, they might not know what an ordered E57 is, but you're using a platform that is doing a scientific computation, so you need to follow specifications to create inputs for the data. So as long as users can follow the specifications for creating the data to use the platform, there's no problem. But when you get users who want to log in and they don't understand how to follow specifications for particular objectives, then there become issues. But that's what support's for, right?
Thanks, Shawn. Michelangelo, if you have an answer, I'll give you the opportunity.
Yes, I think it's related to what I've said before, and I think, again, it is important to point out the fact that really IDS in particular in this case, but those open standards should go over the BSI community and really take the leap to really every AEC operator. We think that it's then that we will see an exponential change and the shift, which is already happening. I think it's mostly a matter of time. So we are happy to help guiding the users in this process. So.
Thank you. I'm sure we could spend a lot more time asking a lot more questions here, but I'm even more sure everyone would like to go and get some lunch. So we will wrap things up there. Thank you all for your presentations. Thanks for joining online, Shawn. We will restart in 35, 40 minutes for the categories of student research and professional research. Thanks again. See you soon.
Thank you very much. Bye-bye.